Good morning, Math 2 students. This is Mr. Flynn. I have here the Math 2 practice for March 30th. Really, a lot of it is review, but I want to shore up a few little things. I'm only going to do a few of the problems for you, and then you can practice on your own. There's also another PDF that has vocabulary that you need to know. So please look that over. Just kind of read over it a few times, make sure you understand it. It's not too hard. I'll start using that vocabulary as I'm teaching as well. But the thing is, we're going to be quizzing on that a little later this week. So I'm going to start with number 1 when it says to simplify this expression. And really, please understand, when we're just adding a polynomial to a polynomial, that addition sign in the middle means we're just going to take everything in the second polynomial and keep the signs the same. So we can drop all the parentheses right now and rewrite 5x to the third plus 3x minus 7 plus 4x to the third plus 7 minus 6x. Notice they all kept the same sign, that second polynomial. Now, the part that I want to just emphasize is that we need to collect like terms. Remember, simplifying, we don't just do this and get done right here. We need to collect the like terms, and like terms are when the variables are to the same power. So I have x to the third and x to the third. That's a like term. And then I'll use a different color. I'll use this color. I have an x, and then I have another x term over here. And then, I can't forget our constants. Our constants are a simple term or a like term. So really I have 3 things I'm putting together. And I'll go back to my red. So I'm going to put the 5x to the third with the 4x to the third. 5x to the third plus 4x to the third is 9x to the third. Keep the exponent the same. Then I'm going to do the 3x and then negative 6x. 3x minus 6x is negative 3x. And last but not least, I'm going to do the negative 7 and the positive 7. Negative 7 plus 7 is 0, and I don't have to put it on. That's my answer. And you can always check your answers on this because I have the key at the bottom. Okay? Again, I like to give you the key, you know that, so you guys can always practice on how to do that. So let's go to number 2, and I'll show you how that works. Not that it's any harder, but again, a little different. We have subtraction. All that means is that everything in here is going to get its opposite sign when we write it all out and drop the parentheses. So we're going to have 2n to the third plus n minus 5n squared. Then everything gets the opposite sign. Minus 4n squared minus n minus 2n to the third. So again, let's look at our colors. We have n to the thirds we're going to put together. We have an n we're going to put together. And we have n squares we're going to put together. So let's just start with the n to the thirds. We have a 2n to the third and a negative 2n to the third. 2 minus 2 is 0. They cancel out. Then we have the n squares. We have negative 5n squared minus 4n squared. Negative 5 minus 4 is negative 9n squared. And then we have a positive n and a negative n. They cancel out. And this is our answer. That's it. So notice in number 2, we are left with just one term. But in number 1, there is more than one term. All right? Please understand, you don't always get down to one term. It's only because those other terms in number 2, the n to the third and the n's, they were canceling each other out. Okay? So you can work on 3 and 4. I'm going to go down to number 5 for you. We've done 6, 7, 9, and 10, but we haven't seen it in in the form of number 5. So it's this binomial, a 2-term polynomial, raised to the second power, which really means 2b plus 7 times 2b plus 7. And now you could either stack it or distribute Notice since there's two terms, it's a double distributing. So I'll use a different color to show it. So 2b distributed to the 2b is 4b squared. 2b distributed to the 7 is a plus 14b. Then we do the next term, 7 distributed to the 2b is plus 14b. And then the 7 distributed here, 7 times 7 is 49. Now again, we only have those like terms to collect. Everything else is done. So we have 4b squared. 14b plus 14b is 28b, and plus 49. That's your answer. Okay? Now you've done the multiplication a lot, but we haven't seen it like that. So on number 8, you're going to have to do the same thing. Okay? Just be careful with that. And you can practice those multiplications. I think you're going to be pretty good at that. I'm only going to go through another couple problems down at the bottom where we're simplifying. This deals with our rules of exponents. Okay? So we always want our exponents to be positive on our variables. And we want, in a division problem or a fraction, we only want the variable on either the top or the bottom. Okay, we can't leave one on top, like an x on top and an x on bottom. That's not simplified. So since we have an x term on top, that's really x to the first. And we have a y term on top, y squared, and we have 3x squared y to the third. What you do is when you divide, because a fraction bar is really division, okay? We're taking the top divided by the bottom, but how you do it with variables to exponents, or with exponents I should say, is you subtract. So we have a 2 on the x, so this is the x's. We have a 2 on the, and then we have a 1, so 2 minus 1. Which one has the highest exponent? The one on bottom. So 2 minus 1 is 1, so we're left with an x to the first power on bottom. And then when we deal with the y's, we have, you can see the exponent is 3 minus 2, and that's 1 as well. And the 3 is a larger exponent, so the y stays on bottom, y to the first power. That's at 1. Now notice there's nothing left on top after we subtract those variables off, so we have to put a 1 up there. And don't forget your 3 down here. Now this is old work. Don't know if you remembered it or not, but that's your answer, 1 over 3x to the first y to the first, or you can have 1 over 3xy, because anything to the first power, you don't have to show it. These two, either one, I'll accept. They're both good, okay? The last piece I want to show you is number 17. When we have variables that have an exponent raised to another exponent, okay? So I'll get that stuff out of there. But really what this means is this is going to be multiplied by itself that many times. Or, if we know our rules of exponents, and we should, we've practiced these before, this is 3 to the first power, y to the first power, x to the third power, all raised to the fourth. When you raise a power, I'll use a different color here now, when we raise a power to a power, or a power to a power, or a power to a power, all you do is distribute it in. Don't multiply the 4 times this 3. That 3 we need to keep, but the exponent becomes 4 times 1 is 4. The y becomes 4 times 1 to the fourth power. The x becomes 4 times 3, that's 12. And then the only thing we have to do is work with that. And 3 to the fourth power is 3 times 3 times 3 times 3. And you can use your calculator. That's 81. Y to the fourth, x to the 12. That's it. Okay? So you can practice the rest of these problems. Shouldn't take you too long. If you need any help, email me. I'll be available between 8 a.m. and noon. And if you need me afterwards, if you send an email, any time of day, if I'm available, I'll respond to you. But also look over that other PDF with the vocabulary. You're going to need that, okay? Talk to you guys later, man. Stay safe.